All right, we're going to be on page 5 and 6 of the April packet. That is the one with the April calendar on the front of it. We'll get to that packet that you guys just picked up in a minute. All right. So today we're going to be doing a transformation activity on Google Slides to explore the functions and the different HK and A values on the vertex form of a quadratic function. So I'm going to first start off by talking about just the common functions, the 4 function groups that we have, and what their parent graphs look like, because you need to know what the parent graphs look like in order to be able to do this activity. So the first one we got here is our exponential. That's our exponential function. And that has a parent, that formula is y equals 2 to the x. Now, can someone tell me how you know that something's an exponential? By the formula.
There's an exponent of that.
Exponent of what?
An x.
Yeah, it's going to have x in the exponent. Right. Your next formula, or your next graph, is called a quadratic. And that's got a parent graph formula of y equals x squared. We know it's quadratic because it has a square. All right. Your next function is a line, otherwise known as linear. The parent graph formula of that is y equals x. Now this last one you may not be entirely familiar with. That is called an absolute value. An absolute value formula or function. And the absolute value function has a formula of y equals the absolute value of x. Now the reason I'm going ahead and starting with these is because you'll be graphing. You'll be given a function to graph on your Chromebooks, and then you'll have to graph the parent function with it. And if you don't know what the parent functions look like or what the formula is, you cannot complete the activity. So now that we're done with that, we're going to go to Google Classroom. So if you guys want to open up your Chromebooks and go to Google Classroom. And just as a quick reminder, on Classroom, I'll go ahead and erase it. Does everybody have these written down? All right. I want to make sure if I erase it. All right. So just as a reminder, on Google Classroom, you've got your stream that Mrs. Myers posts announcements about office hours. And then all of your classwork is in your classwork tab. It's all sorted by week. And then your important info, they'll load in a minute. Give it a second. There it is. You've got everything that's due this week. You've got what we did Tuesday, and then you have what we do Friday. And then just like that, we've got our important info for anything that you need to know for virtual hours, quarantine instructions if you have to be quarantined, your Delta math, and then you're navigating Google Classroom if you forget. But we're going to be going today to the functions transformation activity. Go ahead and click on that. It should bring up a Google slide. Give everyone just a second to get into this before I start moving through.
The first one maybe.
All right. Is everybody in the slide?
Nope.
Does anybody need help finding it? It's the very first one in week 14. Everybody good? Yeah. There. All right. So we're going to be graphing functions with Desmos today. Going to go through a quick. You've got your link up on your first slide to go to the calculator. But so we'll be doing, and then that second slide there, you'll notice we've included the all of your parent functions and what they look like, just so you can get it, you can refer back to them if you need to. So the way this is going to work, we've got our first each one of you will be assigned. Some of you will be working in pairs, but you'll be assigned a slide. Then I'll go through how you're going to do this. So if everybody wants to click on the link to Desmos and go to the Desmos graphing calculator. Should look somewhat like this. All right, so first thing you're going to do is you're going to graph the parent function for this slide. So we'll go back to the slide. What is the parent function for this equation? What does this somewhat resemble? Yep, a quadratic. So we're going to go to Desmos. We're going to type it in. F of x equals x, and then to get your exponent, you're going to hit shift and the 6. That's going to, you see it moved it up. You'll type your square or your 2, and then you're going to hit the arrow, the right side, the right arrow to get you out of the exponent. Then you're going to do your, or sorry, that you'll leave that there like that. So that's your parent function. All right, so now we're going to graph the equation from the slide, which is f of x equals x shift 6 squared.
How you make it squared?
So you're going to hit shift and then the 6 at the same time, and then you should be able to type your 2. Then you're going to hit your right arrow to get out of your exponent, and then plus 3. So now that you've graphed both the equation and the parent function, so you're going to hit the shift and the 6 at the same time, and then type your 2. So what you're going to do is, we don't want screenshots of the graph. We want the actual exported image. So when you take your image of your graph, you're going to either want to, you may have to zoom in, zoom out, you may have to move around. So to move the graph around, you're going to click off the graph and hold down, and then with your other finger, you can scroll around. So you just want to make sure that this isn't too far zoomed out that you can't tell where the numbers are. I don't want to see 50s, hundreds on this. I want to see small numbers so that we can actually tell the change. And then to zoom in and out, you've got your plus and minus over on the right side. You can hit zoom in. And there's your function right there. So once you've got this where you need it, you're going to click on this icon right there, the share graph. Looks like a box with an arrow. Click on it. And it's going to bring up this. And you're going to hit export image. And then you're going to download the PNG. And it's going to appear right here, down in the bottom right hand side. And you're going to hit copy to clipboard. Now, all you're going to do, you guys won't be able to do this yet because I have not given you access. But you'll just you're just going to paste it in and then resize it so that you can see everything. You're not going to be able to paste yet. Don't worry about trying to paste it into the. So you all will have access to this once I'm done with the first two. I just want to give you an introduction and explain how to do this. And then I will give everyone access to it because we're going to use the same slide for the same presentation for everything so that we can all look at it. But so you're going to put your graph in. Now, you're going to identify the transformation, so you're going to identify all the key aspects of this. But we're not worried about domain and range. We're going to take care of that later. That'll be for another day. So the good thing about Desmos is to find, if you're looking for, so the first thing up there would be your y-intercept. So you can hover over. You can hover over, and it'll give you the coordinates for your y-intercept. So then you'll just come back to the slide. And you're going to type in 0, 3. Now your x-intercept, does it intercept the x-axis? No, it does not. So you'll just put none. Now, can somebody give me the vertex of this? Do we know what the vertex is? You can tell me what a vertex is in general.
It's like the point.
So the vertex is either going to be the highest or the lowest point of your quadratic, depending on the equation. It's just going to be where it changes direction. So with this one, our vertex would be our bottom point of the equation, or the graph, which would also be our y-intercept in this case. So we're going to type in 0, 3. And then is this concave up or concave down? Concave up. All right. So that's what you're going to do with each slide. Now we're going to do 4 as well, and then I'm going to assign everybody a slide, and I'll give you guys editing access. All right, so I want everyone to work on 4. We're going to all type this one into our computers because absolute value, you guys need to know how to put this in order to do a couple of these slides. So we got the absolute value of x plus 5. We're going to come in here. We can just delete previous equations.
How do you get a picture of it without screen generating?
I'll show you with this one.
Is snipping tool?
No.
So we're going to type in f of x, and then to get the absolute value, you're going to hit shift, and then the key that's right above your enter key on your the right side. It's just a straight line. That'll give you your absolute value. Then you'll hit it, you'll type your x and then hit it again. So that'll give you your parent graph for your absolute value function. Now then we need to put the new graph in, or the new equation in. Our new equation is absolute value of x plus 5. So we're going to type that in. So then, remember it's the key above your enter key. You're going to have to hit shift in order to get the absolute value plus 5. All right. So now you notice you can't really see that, can you? So zoom out a little bit and drag it. Maybe it'll zoom back in now. Don't know. No. So we'll get the graph situated where we need it to be. And now to get the image of the graph, you're going to come up to the top and hit that little icon that looks like an arrow coming out of a box. It says share graph. We're going to click on that, go down, and hit export image. And so this is what should come up. So then you hit the download PNG, and it's going to pop up in your bottom right corner. You're going to copy it to your clipboard, and you'll come to your slide, click into it, and you can just hit Control V or paste, whatever you prefer to do. You'll paste it onto your slide, resize it so you can see everything. And then all you got to do is input your stuff here. So we need the y-intercept. We're going to come back to our graph here. And the y-intercept going to be right on that. Hover over it. 0, 5. Okay, so we'll come back to the slide. Put that in. Now our x-intercept. This doesn't intercept the x-axis at all again, so we're going to hit none, or we're going to type none. Now our vertex, where it changes direction, is going to be the y-intercept as well in this case. Sometimes it will not play out like that, but sometimes it does. Now does this open up or down? Up. All right. Now are there any questions on this? Okay, so I'm going to go ahead. I'm going to give you editing access.
I also wrote the directions right there on the board.
Yeah, so your directions are also up on the board. Okay, I will be giving you editing access. That means you can edit. This will allow you to paste and type onto the slides. Now I am trusting you to be mature about this and do not alter the equations. Do not put anything inappropriate on the slides. Just do your slide and then you can look at other people's.
Can't we just like copy it?
How do we know it's right first?
I'm trusting you because I know you guys are mature.
Oh, you do.
At least one, at least.
Okay.
This class has never been right.
All right. Now, you guys won't be able to access this until you hit the refresh button on your computer, which is up here. Hit that refresh and you will have access. If you guys mess this up, I will give a lecture for 2 hours over this. I have no issues giving a lecture over this.
Which one's over this line?
Yeah.
What if you accidentally?
I'm gonna give you your slides. All right.
You assigned our partners,
I am assigning your slides now.
our partners. You said we were.
Some of you will have partners. You will find out.
All we have to do is type it in and screenshot.
Not screenshot. You're gonna export
Right.
because we need to be able to see
That's
it.
it.
Okay. And then the next part we'll cover when everybody gets done with that. All right. Slide. So we're starting on slide number 5. Shelby, you've got slide number 5. Logan, you have slide number 6. Jaden and I'm sorry, I can't say. Elmadin, you guys have slide number 7. Scott, you have slide number 8. Mara, you have slide number 9. Haley, you have slide number 10. Avery has slide number 11. Then Colin and Evan, you guys are partners on slide number 12. Nathan and Nor,
Which one? Which makes it?
B. You guys have slide number 13.
13.
Yep. Jacob, you've got slide number 14. Eric and Ben, you guys have slide number 15. Mackenzie and Summer, you guys have slide number 16. Joe and Nathan, F, you guys have slide number 17.
Nice to meet you. How was it again? It's good to be working.
And then, do you not put 18 on here?
So basically, we're going to like,
Oh, 18. Ari, you have slide number 18.
Oh,
some of the lucky numbers.
I love it.
you said I was.
Where's 19?
Control B is how you.
Cameron, you've got 19. Tori, you have 20. Lauren and Mackenzie D, you guys have 21. Trent, you have 22. Noah, you have 24. And then Tyler, Logan, H, and Joshua, you guys have 23.
I have the last slide.
Does everybody have a slide now? All right. Now, once you're done with that, what you're going to do, well, I'll give you guys a minute to get to your slide and then I'll.
Guys, make sure when you're like putting that graph on the slide that you're putting a good picture of your graph, that it's not zoomed out, that it's nice and centered, because other people in the class are going to be looking at that graph and have to write down their answers based on the graph.
All right. So, is everybody on their slide? All right. Hey, I need you guys to look up here.
Things X equals X.
All right. So, your next step, after you finish doing your slide, your next step is going to be to go back to that April packet that we were on, and you're going to be on page 5 still. Now, one thing to note is we did have to add slides to your guys' presentation because you have a bigger class. So there are more slides than there are numbers on this thing, on the paper. So they're broken up by slide, not by slide, but by groups of slides. So you're going to do for each one of the slides, regardless of whether or not it was assigned your slide or not, you will do this for every one of them. But we'll do the first 2 that we did together so that you guys can kind of see what you're doing. So we're on slide number 3. So number 3. Now, what do you notice? What happened to the new equation? How did we get from the parent graph to the new equation? What did we do? What happened?
Added 3.
So what does that translate to in just visual terms? What happened to the graph? So added 3 is correct, but what is that? It raises the graph up, right?
Right.
So so for number 3, you would just write up 3. Now number 4, let me go to that one real quick. What happened from the parent graph to the new graph. What happened? Up 5. So, after you finish putting your graph and all of the x, y intercepts, vertex, concave up, concave down, depending on what graph you have or what equation you have, you're going to go ahead and you're going to note how the new equation changed from the parent graph. You're going to note that in your packet, and then you're going to go through and do all of the other ones. All right, if you have questions, just raise your hand.
Not quite sure. I know she did.
You need to be graphing the parent graph and the equation from your slide. Guys, make sure you're doing both of these steps. Graph the parent graph and the equation from the slide. So graph this one.
What do we do now?
What's your name? I know your name, but
There is an
Joseph D. Ward. Joe Dare.
I mean, I don't know that information, but it does have an x-intercept right there. So you just go to your graph and like that.
What is it?
On here.
Some of these equations will have multiple transformations. You may have up to 4.
Out of these, what is it?
Out of order, I'm updating it every second. Out of order.
Does it have absolute values?
And y'all are changing the font.
Does it have absolute x on it?
Wow.
Does it have x on it too? So you need to graph this first, and then you're gonna type that in. So you need to graph this.
I don't know.
Oh my God, this is really good.
You guys literally just don't. Exactly what you're talking about. He said, don't edit anymore. You guys are exactly opposite of what he said.
Well, everyone can read it.
Oh my God.
That's the only thing that matters. Yeah, it looks good. Looks professional. I'll get rid of the gray.
No, I know this is good.
So stuff like step 2, graph the equation from the slide. Then go to your.
Deleted it.
I got another picture.
It's not gonna have one. Technically, the x-axis is an absolute for that one, so it's whatnot.
Alright, wait, let me.
I don't know if it's supposed to look like this or.
Someone's still in a whole bunch of
Alex,
slides.
do all a little bit so everyone can see.
What the heck? What the heck?
Someone just
Like I did that.
What the heck?
I know, that's good.
Everyone, don't do anything.
Looks like we're getting 2 hours.
Look at actually.
Dude, are you guys dumb? Back foot.
I tried that. Oh, he's doing it. Well, It's not working.
Do the undo thing.
Yeah, they already tried it.
I tried.
Everyone do it.
There you go.
See, look, I'm doing it. I'm doing it. That's what I'm doing.
Who broke it?
I got mine and that's all I care about. No, it's there. See? Bam.
What is it? Observation.
It's called control Z. It's like Joe. Yeah. The fun is weird.
It had a baby. It's pregnant.
There's one midnight version that we know.
If he says it's on screen.
It's not like. You got that.
So that'd be.
It's actually bigger.
Yeah.
I did. Come here.
Oh, that guy.
I saw that. I saw that. Yeah, I'll threaten you, whoever you are. No! Wait, what happened? What happened to my slide?
I was fixing
You do not fix my slide.
Hey, Scott, can you
I'll make it
zoom in a
worse.
little bit more and take another picture of your graph? So it's really hard to see the numbers.
Yeah. I'll start hitting with the pictures.
Who has graph 9? Raise your hand if you have 9. Can you redo your parent function? You need to be graphing the parent function for exponentials.
So there's no
Because
way.
yours is just showing a horizontal line at 2, I'm
Alright, I want something.
I think you just have.
You're all around. I got some
So
Did you say you're doing this?
I'm doing it.
Yeah.
What are you doing?
Oh, we're not gonna do it. Do we do the domain and green?
Don't worry about the domain and range. We'll do that out there.
Okay, so why?
What is that?
It wasn't big.
There's no X in this.
who had graph 10?
Yes.
Who had graph 10?
Alright.
I need you to zoom in a little bit more on your screen. So far, zoom down towards the CS information.
Oh, that kind of hurts my eyes.
I'll do the rest.
Yeah.
Who had graph 12? Who had graph 12? You didn't graph your parent function? You need to graph y equals x squared also.
Yeah.
That was the other one.
That's basic.
Yeah, it said if you ship, that's the one I need.
Who had 19? I need you to zoom in a little bit more on your graph.
I know, is that?
Who had 22?
That's dope.
22.
23, they did
Who had 22?
23's doing some jazzy.
Hi, Laura.
Can you zoom in a little bit more on your graph? That way we can actually see how far since it's like has increments of like increments of 5. Like how far the students hold on, Haley.
I got
Even my computer.
Yes, purple. I like purple.
You can't put That is a bra. It's a bra and that pops up. It's a bra and that pops up.
What the heck is that?
It's a bra. Yeah.
Yeah.
Copy.
We got Peter Griffin. That is horrifying. Seriously. Did you do that? Oh yeah, you can do that.
Oh, there we go.
Valerie?
Dude, y'all are on mine right now.
Who's Valkyrie?
Who's on?
Bro, who just changed mine to rainbow?
Stop changing the background, you guys. Leave them white, like I said.
Guys, please leave the backgrounds and the format of the slides alone.
What, now they're moving around the slides. Mine was just 18. What the freak?
Yeah, mine was 21.
Now close to the 5. Now mine's 19.
Linear. Well, no, but this isn't linear, right?
Who's changing this stuff? Okay, I think we're like.
Where'd my stuff? I forgot what-
They're moving the.
Oh, wait, I know.
I don't know, well, the, so.
What's the Christmas theme?
Wait, go back to the.
Who's number 13? Who's graph
These have
13?
changed.
They're changing now the numbers.
These have changed.
The slide numbers.
What?
The numbers have changed. Somebody's changed all the numbers.
Well, who is the negative absolute value of x plus 7?
That would be Nathan B. And
Did you want me to?
that should be slide 13.
You guys need to paste a picture of your graph. Make sure you have your parent graph and then the new one.
Whoever's messing with the slide, put it up.
I've got all of the sides.
Oh, they're being.
A lot of them are like down or zero.
Oh, yeah.
The side one.
It's not, it doesn't.
Picture.
Yeah, it is. I tried. It's only one.
No, that's where, that's
Yeah,
just
I used to
the.
have to.
What's it called? Where it's
Yeah.
sit right
Everyone
there.
else did here.
Oh, yeah, I remember.
Oh, yeah, I remember
that.
I bought some of that yesterday.
Oh, yeah, I probably would.
Yeah, but I didn't buy the. I didn't buy, I bought the brand new stuff that's like $12.
Look at those.
I'm just saying.
Which one do you have? Look at that. Which one is it?
All right, I'm just gonna let you know we're taking your editing rights away for a second. We gotta fix it.
Good, please take their editing rights away. That one's specific.
While you're waiting, what you can do is go through the slides that are already done and figure out the transformations. What do you notice has changed? Go ahead and list them through. For the last two, you can just write them where you've got space. Since there's not, you can just write them in that same box. They should fit, probably. Not write them where you've got space.
I think I figured it out.
What was I slow that one?
Yeah. Yeah, I think one of them deleted.
Are we allowed to eat this class? I don't care.
They can't have peanut products.
Okay, Foggers.
I don't understand.
I think it's all.
We're supposed to.
Do I have a copy?
Oh, yeah, I just said.
Text me tonight, okay, remind me. Text me tonight.
I'm sorry.
All right, is everybody done noting the transformations? We're gonna go ahead and go over them. All right. So, we've already done 3 and 4. So let's go number 5. We have x minus 7. So, what do you know? What changed between this graph and the parent graph? Your parent graph is your red one. What happened? How do you go from the red to the blue? Down 7.
You guys have a quiz over this next class, so I would really try to pay attention and understand what these changes are, because you're gonna have a quiz next class over it. So if you wanna improve your grade, that's the best way to do it.
Okay, now, we're gonna go back here. So let's look at 3. Let's look at the common theme between 3 and 4. So what do you notice is the same about 3 and 4? What aspect of these formulas is the same? Yes, they both, the graph goes up what part of the formula tells you that it's going to go up though?
The plus sign.
The plus sign. So your plus sign here, this would be in corresponding to your variables that are up here. That's your k value, aka your vertical shift. So if it's plus, it's going to go up, and if it's minus, it's going to go down. So hence 5 goes down. Now number 6. What happened? How do you go from the parent graph, which is your green, to your new graph, which is your black? Down 5. So you're going down 5. Right. Now number 7. How do you go from your parent graph, which is your black, to your new graph, which is your red? It's kind of hard to see on this one, but what direction do you go? Yeah, right 3. All right. Now let's look at 8. How do you go from your parent graph, which is your blue, to your new graph, which is your green? Which direction are you going? Yes. You're going right 1. So what kind of conclusion can you draw from having something that's inside the parentheses? What's going to happen to the sign?
Depending on the sign, it doesn't go left or right.
So elaborate that on a little more. If it's a minus, yeah. So if it's just basically opposite, because you're positive. If you're looking at a graph, your positive is to your right, but you're gonna switch the sign on the inside, so it's always gonna go opposite. So on number 9, we've got something in the parentheses. Our parent graph is the blue, and our new graph is the purple. So where's it go? How do we get from the blue to the purple? What?
To the right 5.
To the right 5. All right. Now then 10. Our parent graph is the red. Our new graph is the green. How do we get from the red to the green?
Over to the left 4.
Left 4. All right. Next one, 11. Parent graph is blue or purple, bluish purple, and I think that's black. Dark green or black. What direction are you going, or how do you get from the parent graph to the new graph? Left 9. All right. Now, there's a couple different transformations that happen in this one. So our parent graph, wait a sec, this is graphed wrong. So our parent graph should be this. It's close. Close enough.
Yep, yeah, that is it.
No, I got it. It's fine. I drew it. So your parent graph is this one. Your new graph is your blue one. So how do you get from, who can give me one of the transformations that get you from your parent graph to your new graph?
Mirrored over the x-axis.
Yeah, you're going to mirror it. And then what's the other one? I'm going to write these up here. So you're going to flip it. And then what's the other one?
Up 6.
Up 6. All right. Now we got this one. There's a couple transformations with this one as well. Who can give me one of them?
Left.
Sorry.
It moved to the left one, I think. I can't really see. From
So-
here.
Based on what we know from the equation, it's hard to tell with the picture because the numbers are small. This one's got bigger numbers, but based on what we know from the equations, what is this going to tell you?
Left or right?
Yeah. Yeah, so you're going to go left 7. You were correct on the direction. The number was just, it's hard to tell what the,
Look at that 50.
yeah. So you got left 7, and then there's one more. Yep, you're going to flip it. All right. Number 14. All right. How do you get from your parent graph, which is your blue, to your new graph, which is green?
Flip it.
Flip it. All right. Again, there's multiple transformations for this one too. Who can give me one of them? If you can't tell by the graph, what is the equation going to tell you? Well, let's start with what's in the parentheses. What's that x plus 3 in the parentheses going to tell you? What direction is it going to go? Left. How many? 3. All right. And now we've got a -7. So what's that tell us? Down 7. You got down 7. All right. Number 16. We've got 2 for this one as well. So you've got, who can give me one of the transformations? Up 1. What about the other one?
Right.
Right 3. All right. Move to the next one here.
The next one is swapped. Blue's actually going to green.
What?
Blue's
Oh.
going to green.
So your parent graph is your blue.
Yep.
Your new graph is your green.
Yeah.
All right. So what happens between the parent and the new one? It got narrower. Yeah.
Yep.
So we're going to write narrow. So, well, let me go ahead. I think the next one is. Yeah. All right. So our parent graph is our red. Our new graph is our blue. What happened with that one? So our parent graph is our red. Our new graph is our blue. It got wider. So this would be our A value up in our equation. Our A value, so I'm going to write this up here for now. If A greater than or equal to 1, it's going to be narrow. It's going to narrow it. Then if A is less than 1, it's going to widen it. Does that make sense? All right, move on to the next one. All right, so number 19. Okay. Parent graph should be that. Parent graph there, new graph is in the red. So, how did this one change? Based on what we already know about how to use the equations to tell us, how did we get from our parent function, which is y equals x, to 3x minus 2? What? There's two transformations in this. So let's go with, is there a horizontal shift in this function at all? Is there any H value? Anything in a parentheses? Nope. All right. What about a vertical? Is there anything at the end?
Mhm.
So what's that going to tell us?
-2.
It's going to go down 2. And you got a -2, so it's going to go down. Now, this is an A value. On lines, it's a little bit different than your exponents, your exponentials, your quadratics, and your absolutes. So on a line, the A value, if it's greater than 1, just means it's steeper. You're going to write steeper. If it's less than 1, it's more gradual. It's not as steep. All right. Number 20. So same sort of thing. We've got negative, except this will have technically 3. I'm going to write this one down here. I know these are really out of order. I apologize. But so we've got 3 transformations on this one. Who can give me one of them? Up 1. All right. Now what? What's our A value going to tell us? We got 2/5. What's that going to tell us? Other way. So it's not steeper, but it is going to tell us the steepness of it. But it's 2/5 less than 1. So it's going to be more gradual, so less steep. All right, and then we have one more. Do you see it?
That's weird.
Yeah, it's going to, well, so it's not technically mirrored. It's just, it's negative slope, so it's going to decrease. So it's going to decrease. All right. Now, 21. We've got 4 transformations in this one.
Mirror.
Yep, we've got a flip. What's another one?
Left. 1.5. Down. Down.
You are right about the left, but the value's wrong.
2.5.
Oh, it's
So what tells us which way it's going?
1/2.
So what part of this equation tells us which way it's going to go, left or right?
-1/2.
No. It's what's in the parentheses, right? Because that's your H. So you're right about the left because it's a positive. So you reverse it. So it's going to go left. Your parent function is your green. So it's going to go left 3. Now, what does that 1/2 tell us?
You're gonna go.
Up here. So is 1/2 greater or less than 1? Less than 1. So what is that going to tell us? Wider. All right. And then what's the last one?
Down.
Down 5. All right. Now 22. All right. So what's the first thing? Yep, down 3. So it goes down 3. Then what? Left 2. And then flip it. All right. Got 2 more. All right. What's this one going to do? It's going to have to go up here. I can't play down anymore. We got 23. What's that one going to do?
Right.
To the right 3. And there's one more. It gets wider. Right. And last one. All right. What's going to happen to this one? What is it? Narrow. Flip. And then up 3. All right. Now, does anyone have any questions on this part? Okay. So I'm gonna go back out of this. We're gonna stay, you guys are gonna stay on that packet that you're on. We're just gonna do a little summary real quick. All right. So you should already have all those slides filled out. That's everything that's on the board there. All right. Now, does everybody have all of this written down? Can I erase this?
I need 22.
You need 22? It's down 3, left 2, and flip. All right. So just to review, I'm going to give you an example, and we're going to do the variables for a quadratic here. So we've got f of x equals, let's do -2 x plus 3 squared minus 5. All right. So we've got an a variable, an h variable, and a k variable. What's our a going to be? What's our a variable? -2. What's our h variable going to be?
X plus 3.
Yeah, so you've got 3. Now, remember with your h variable, I'm just going to put a note in there, little star, should be opposite when you go to talking about the transformation. And then what's our k variable? -5. All right, so now that we know this, what can you tell me about how this equation goes to comes from the parent graph? What are the transformations? So what is our a variable going to tell us? It'll tell us 2 things. What's it going to tell us? Narrow and wide. So is that going to be narrow or wider? Narrow. And what else is that going to tell us? Think about what's attached to that 2. What's in front of the 2? What's that going to tell us? What did that tell us on the other ones? Flips, right? Going to tell you if it flips or not. All right. And now, what's our h variable going to tell us? Which way is it going to move? I think I heard it. Left. Left, how many? 3. And then what's our k variable going to tell us? Down, how many? Down 5. So, this same concept of the a, h, and k variable, and your h always being opposite of what's in what you see, it's always going to flip. That applies to the exponential, the quadratic, and the absolute values. The absolute value has the a. It actually just changes how far open it is. The only difference would be your linear, which is I kind of touched on it a little bit earlier. So you don't have, well, you could have, I guess. So you've got, lines are a bit different because your k variable now is your y-intercept. So your k actually equals your b, really just your y-intercept. And then your m is your a variable. So a, which is your slope. Now, If your M, like I said, if your M is greater than or equal to 1, it's going to be steeper. And if M is less than 1, it's going to be less steep. All right. So does anybody have any questions on this part? All right. We're going to move to that new packet that you guys picked up today. We're going to be on the back of the first page, and we're going to look at the first two graphs up at the top of that. All right. So you guys are not you're not going to be graphing them right now. You're not going to be doing the vertex or the axis of symmetry right now. All we're worried about is the vertical shift, the horizontal shift, and if it's concave up or down. So, looking at the first equation, what's our vertical shift going to be? So we've got negative x plus 1 squared plus 7. What's going to happen? Where is it going to go vertically? What is it? So would that be your vertical or your horizontal? Which direction is left and right?
It would be
Horizontal.
oh, that's what
So your horizontal shift, yes. Left one. Your vertical shift is going to be up or down. How much it moves. Is it going to go up or down? Up. How many?
7.
Yep. And is it concave up or concave down?
Probably up.
Down.
Down. Do you know why it's down?
Negative.
Because it's negative. All right. Now let's look at the second one. How is it going to move vertically? Is it going to move up or down? Down. How many? Yep. And horizontally, which way is it going to move? Which direction?
Right.
Right. How many? Yep. Right. 2. And is it concave up or concave down? Oh. All right. So your homework is going to be to finish the graphs on the front page and then the last 6 on this page. Don't worry about this second page yet. We'll get to that later. All you have to do is do the vertical shift, the horizontal shift, and the concave up or down. Don't worry about graphing them, vertex, or the axis of symmetry right now. Are there any questions? All right.